Hi, Joker, you a long time. How's the maths going, bruh? I'm sure you are killing it. You are massacring it. Hmm? Awesome, bruh. Awesome. Keep it up. Keep it up. I believe in you, bruh. Yo, I believe in you so much. Yo, Joker. If there's anyone that I believe more than anyone, it's you. I'm sure you'll do wonders. This, okay, so keep it up. Keep it up. But remember, the restriction is that x cannot be 0 because the LCD, you see in the denominator, we cannot afford to have zeros in the denominator. So if we have zeros in the denominator, the restriction says x cannot be 0. We got a final answer that x is equal to 0. So that means x cannot be 0. Right? Which means here, we have no solution. We actually have no solution. Alright, so the procedure must be followed. Sorry guys, I'm just running through these. Literally. Okay. I am running through these. Okay, so first step, this is a fraction equation. We look at the denominator, we factorize where possible. We can see the first fraction. We can take out a common factor. Second fraction can't be factorized. Third fraction on the other side of the equal sign, we just simply write brackets around the denominator. Then what is the LCD? The LCD here, we have x and x, they are common for two fractions. So we write down the x. We have x plus 1 and x plus 1, they are common for two fractions. We write down x plus 1 once. That's the LCD. The restriction is that based on this, x cannot be 0. Based on this, x cannot be negative 1. The thing is, we are looking at what would make the denominator 0 here. If 0 is in the denominator, it will make the 0 a denominator and it will be undefined. Here, if x is negative 1, you see, negative 1 plus 1 will give you 0, and then that's 0 times anything will give you 0, and that will be a 0 in the denominator. We can't have that, so we say x cannot be negative 1. So when you write your LCD, write down your restriction immediately. Now you multiply each term by the LCD. So if we multiply here in the numerator, this x into x plus 1, what happens? They both cancel. We are left with 7x minus. If we multiply this LCD here at the top, the x and the x cancel, x plus 1 gets left behind. If we multiply by the LCD here in this numerator, the x plus 1 and the x plus 1 cancel, x gets left behind, so we say 3 times that x. Now we can solve the equation. We distribute the negative 5, negative 5x minus 5 is equal to 3x. Then we isolate the x on one side, because this is a linear equation. We will isolate the negative 5 on the other side. Then what 7x minus 5x, that gives us 2x minus 3x, which is equal to 5. So that gives us negative x is equal to 5. We divide both sides by negative 1 because the coefficient of x is negative 1. X is equal to negative 5. So that is basically how we would go about it. If we look at the restriction, there's no value that goes against this x value that we have. If the restriction had a value that said x cannot be negative 5, we would have said x cannot be negative 5. Because the restriction is basically don't go against this, we accept this answer. It is correct. Let's do the next one. Okay, we don't have that much time, that's why. So once again, the first step, look at the denominator, factorize if possible, apply the sign change rule if there's a need. So here at the bottom, we can see there's a difference of 2 squares. So we open 2 brackets, plus minus. We say x and x, square root of x squared is x. Square root of 4 is 2. X squared is a perfect square, 4 is a perfect square. This is a difference. So we know this is a difference of 2 perfect squares. So when we factorize it, we open 2 brackets of x plus 2. Okay, we say plus minus, we take the square root of x squared, we get x. Square root of 4, we get 2. That's basically how we factorize that. Plus 2 over. This here, we apply the sign change rule. We can take a negative, and then we swap around the 2 and the x. Take the negative back, negative times x gives us back negative x. Negative times negative 2 gives us back positive 2. So this negative sign and this positive sign will give us a negative sign. Okay, so the sign now, because we multiply these two, the plus sign changes to negative. So we have x plus 6. Okay, is equal to negative 1 over x plus 2. Now, we put that in brackets, we put that in brackets. I think now it's time to write down our LCD and the restriction. So when we write down the LCD, x plus 2 and x plus 2 are common for different fractions. We take the common base with the with the highest exponent, but they are common, so we write the x plus 2 once in brackets. X minus 2, they are common. Is a product, we write x minus 2 as a product to x plus 2. X minus 2 and x minus 2 are common. X plus 2 and x plus 2 are common. So basically we have that as the product of our factors of the LCD. Then the restriction. In this bracket, what would make x be, make the bracket 0? That's if x is negative 2. So we say x cannot be negative 2. In this bracket, what would make the bracket be 0? That's if x is positive 2. 2 minus 2 is 0. So we say x cannot be 2. So those are our two restrictions. X cannot be negative 2 based on this bracket. X cannot be 2 based on that bracket. Then we take this LCD, we multiply by it in the numerator for all these fractions. Now if we take this LCD, we multiply at the top, it means that the x plus 2 will cancel that one. The x minus 2 will cancel that one. What are we left with at the top? Just x plus 6. If we take this LCD, we multiply at the top. This x minus 2 and that x minus 2 cancel. We are left with just x plus 2 alone here at the top. So we say minus 2 into x plus 2. And then if we take this LCD, we multiply here at the top. This x plus 2 and that x plus 2 cancel. The x minus 2 gets left behind. So that means negative 1 into x minus 2. Because that x plus 2 and that x plus 2 cancel, the x minus 2 gets left behind. Okay. Then we can now solve the equation. X plus 6 minus, we take the negative 2 inside, negative 2 times x, negative 2x, negative 2 times positive 2, the negative 4 is equal to negative 1 times x is negative x, negative 1 times negative 2 is positive 2. Then we can see this is a linear equation. So now we are going to isolate the x. So x minus 2x. Take the negative x over, plus x is equal to, the 2 is already positive. The negative 4, if it transposes, it becomes positive 4. This negative 4 becomes positive 4. This positive 6 becomes negative 6. Then x plus x is 0. Sorry, no, x plus x is 2x. 2x minus 2x gives us 0, which is equal to 2 plus 4 is 6. 6 minus 6 is 0. Guys, if we get an equation and the numbers are the same on either side of the equal sign, that means x can be any real number. Now, if you know what real numbers are, you know that real numbers are all the numbers in the number system. You could substitute any value of x in this equation. It will satisfy the equation. So x can be any real number with the exception that x cannot be negative 2 or x cannot be positive 2. We avoid these two values. X can be any real number. Whenever you have a situation where you arrive at an equation and then the equation basically shows you that one number is equal to another, you say x can be any real number. The only exception is that we say x cannot be the negative 2 in the restriction and the x cannot be 2 in the restriction. This is a special case and we always need to take it into consideration because it is possible. That's special case 1. Special case number 2. If ever I don't know why this orientation is like this now. Yeah, if ever you find yourselves, guys, in a situation where, for instance, we have an equation and a number is equal to maybe like this. We have different numbers, then that means no solution. It always means no solution. So special case number 1 is that if you have same numbers on either side, at the end it means x can be any real number, but then you exclude the restrictions. If you have a case where you have a number, different numbers on either side, it means there's no solution. So those special cases are cases that you need to be aware of. Let's continue. possible. The next step, write down the LCD. So x minus 1 and x minus 1, unique, common, base with the highest exponent is x minus 1. X plus 2 is unique, so we include it as a product of factors in the LCD. Then we write down the restriction, guys. The restriction is x cannot be, what would make this bracket 0? X cannot be 1. What would make this bracket 0? X cannot be negative 2. Okay, then you take the LCD, you multiply here in the numerator. If you take the LCD, you multiply here, x minus 1 will cancel, x plus 2 gets left behind. So when you have two or more terms, you put it in brackets. So x minus 2, he gets cancelled, x plus 2 gets left behind. So that means I'm going to multiply x minus 2 with x plus 2, minus 5. X plus 2 cancels, x minus 1 gets left behind. So I'm going to multiply negative 5 with x minus 1. X minus 1 cancels, x plus 2 gets left behind. So I'm going to multiply 7 with x plus 2. Then I am going to multiply out. What's x times x? It's x squared. What's x times 2? Plus 2x. Negative 2 times x, negative 2x, and then minus 2 times positive 2 is going to give me a negative 4. Minus 5 times x into minus 5 times negative 1, negative 5x plus 5. 7 into x, 7 into plus 2, that's 7x plus 14. Okay, then this one I can see is not a linear equation, it's a quadratic, because I have variable with the highest exponent, which is 2. So I'm going to group like terms. Minus 5x, take the 7x, negative 7x. 7x goes over, it becomes from positive to negative. Minus 4 plus 5, take the 14 over, and minus 14 equal to 0. Then we add the like terms. Guys, whenever you move terms over to the other side, the sign will change. That's why 7x became negative 7x, 14 became negative 14. We add the like terms now. 2x minus 2x is 0, minus 5x minus 7x is negative 12x. Negative 4 plus 5 is 1. 1 minus 14 is negative 13. Okay, now this trinomial, the last term is negative. What does that mean? In your brackets, when you open them, you are going to have different signs. Okay, different signs. But this negative sign, the highest factor is going to have a negative sign. So we are going to have negative, positive. Those are different signs. The highest factor out of the factors of 13 is going to have a negative sign. So the factors of 13, 13 and 1, the highest factor is going to have a negative sign, and then plus 1. If you say negative 13 times 1, you get negative 13. If you add these two together, you get negative 12. So it works. Then I'm going to write x and x equal to 0. This is the factorization. After that, we apply the 0 factor law. So we say x minus 13 is equal to 0, or x plus 1 is equal to 0. These are two linear equations. You solve them independently. Take the minus 13 over, you get x is equal to 13. Take the positive 1 over, you get x is equal to negative 1. You check these answers against the restriction. We were told x cannot be 1. We don't have a 1 here. Very good. X cannot be negative 2. We don't have a negative here. So that means both of these answers are acceptable. We can take them for ourselves. Okay. Number 5. 3x plus 4 over x plus 6 is equal to 3x plus 2 over x minus 3 minus 23x over x squared plus 3x minus 18. So here's another nice problem. We are going to first and foremost do what? Look at the denominator and do what after that? Factorize if possible. So this x plus 6 can be written in brackets. This x minus 3 can be written in brackets. From two terms it becomes 1, and you've taken out the highest common factor of 1, which you cannot see. You can factorize this trinomial. What does it become? Now I'm going to put any 2 or more terms in my denominator in brackets. Why? Because that helps for when I multiply each term by the LCD. 2 or more terms in the numerator I put in brackets. This is one term, so I don't have to put in brackets. I'm going to now factorize this. Okay, negative sign means different signs inside my bracket, but the highest factor will have a positive sign. So I'm going to say positive, negative. Factors of 18, okay, I have 18 and 1, that won't work. I have 9 and 2, that won't work. I have 6 and 3, that will work. 6 and negative 3 will work very good. Because 6 minus 3 gives me 3. 6 times negative 3 gives me negative 18. Perfect. So I'm now going to put x and x factorized. Now I can write down the LCD. X plus 6 and x plus 6 are common. I'm going to write x plus 6 as a LCD. X minus 3 is unique as well, but common. So I'm going to write x minus 3 once as the LCD. Then I write my restriction. So the product of x plus 6 and x minus 3 is my LCD. Then I say x cannot be. What would make this bracket be 0? That's if x is negative 6. What would make this bracket be 0? That's if x is 3. So I say x cannot be negative 6 and x cannot be 3. Because we don't want 0 in the denominator. And if we substituted these values, we'd have 0 in the denominator, which means our equation is undefined. Then we take this LCD, we multiply at the top. Who cancels? He cancels. Who gets left behind? X minus 3. So I'm going to say 3x plus 4 into x minus 3. Who gets cancelled? X minus 3 gets cancelled. Who gets left behind? X plus 6. So I'm going to say 3x plus 2 into x plus 6. Who gets cancelled? He gets cancelled. Who gets left behind? Who gets cancelled? They both get cancelled. Alright, they both get cancelled. So this one, both get cancelled, guys, both of them. So yes, mean that 23x is alone there. Now we can solve the equation. We've gotten rid of the denominator. So we FOIL 3x times 3x, 3x squared. 3x times negative 3, negative 9x. 4 times x plus 4x. 4 times negative 3, negative 12. Equal 3x times x, 3x squared. 3x times 6 plus 18x. 2 times x plus 2x. 2 times 6 plus 12 minus 23x. Now we can add and subtract the like terms. Let's transpose them. We have 3x squared, take the 3x squared over negative 3x squared. Its sign changes from positive to negative. Negative 9x plus 4x. We take the x terms, take the 18, negative 18x. Take the 2, negative 2x. Take the 23 plus 23x. Okay, the numbers. Alright, I can see that my x squared term is going to disappear, which means I'm going to have a linear equation. So I'm going to take my numbers. 12 is already on the other side. It's positive. Negative 12 I'm going to take over. It's also going to be from negative 12 to become positive 12 on the other side. Let's add these like terms. 3x squared minus 3x squared will give us 0. Let's go to the x terms. Negative 9x plus 4x is negative 5x. Negative 5x minus 18x is negative 23x. Negative 23x plus 23x is 0. I'm left with negative 2x on the left hand side. Then on the right, 12 plus 12 is 24. Okay. When adding these like terms, guys, take your calculator if you need to. You know that the answer is going to have x in it, but what you do is you take your calculator and you say negative 9 plus 4 minus 18 minus 2 plus 23. Your calculator will give you the answer negative 2, and then you put the x next door to it. Makes life very easy. Now that you are here, you divide by the coefficient of x, which is negative 2. What you do on the left, you do on the right. X is equal to negative 12. This answer here does not go against your restriction, so therefore it's an acceptable answer. We are done. We are done. So these were corrections I just needed to do quickly for the purpose of my classroom, but I hope that's very clear for everyone. So thank you so much for joining in the live. Hopefully this, even though it was quick, fiery stuff, really was helpful, all right? Because when we are dealing with fraction equations, this is the method we need to take into consideration. We always, step one, look at the denominator, then factorize if possible. Then we find the LCD and write down the restriction immediately, okay, so that we know which values of x to avoid, which basically would make the denominator 0. Step The next step is you multiply each fraction by the LCD there in the numerator. Then that will give you an opportunity to see who gets cancelled, who gets left behind. That way we are able to remove the denominator. Then you expand and simplify and get to solve either a linear equation, that's an equation that has x as the exponent 1 as its highest exponent for x or whatever variable you have, or you get to solve a quadratic equation. That is an equation that has as its highest exponent x, which is powered by 2. When you solve a linear equation, guys, you always isolate x and you solve for the unknown using what I call the additive inverse and the multiplicative inverse. The additive inverse is just simply you transposing terms and signs changing. The multiplicative inverse is where, when you get at the end where the coefficient is isolated with x, you divide by the coefficient both sides in order to get to the answer. Then you check your answer against the restriction. Okay, if it's a linear equation. Or you could get to a place where you simplify and you get a quadratic equation. Okay, so the goal there is to then write your equation in what? In standard form. Okay, ax squared plus bx plus c is equal to 0. Then thereafter, you factorize. Okay, you know most. You factorize in that you get 2 brackets equated to 0. You then apply the zero factor law, which is you take the expression in your first bracket, make it equal to 0, or you take your second expression, make it equal to 0 in your bracket. Then you get what we call your roots. Your roots basically are your solutions. X is equal to, or x is equal to whatever. Then you check your answer, your roots. We call the solutions, guys, roots. You check your roots against the restriction, and then that's how you conclude. So this is the step-by-step process of solving for a fraction equation, guys, and it shouldn't be difficult. So I've done this. I've just done that. And then we also saw that there are these 2 special cases that you need to be aware of. Okay, special case number 1, whenever you get to a place where after solving, you get to a place where you get the same number on the left and the right, that means that x can be any real number. You can simply say x is an element of real numbers. Then you write down the restrictions because you know you need to exclude those values from the answer. Special case number 2 is when you basically get to a place where x gets eliminated, but then you have 2 different numbers on either side of the equal sign. That simply means that x has no solution. So please take note of these 2 special cases that you sometimes get yourself into the situation of when solving for x. Be aware of those, and yeah, let the maths flow. Okay guys, so that is basically it. Thank you so much. I hope you guys have a great day. Maths is a game. Let's play it, and let's get the distinctions and win and win and win. Thank you so much. I hope you guys have a great day further. If you're with me from the beginning of the live, please do enjoy your day, and thank you so much for being amazing as a math student. Ciao ciao.